We have a theorem. Theorem states that if A is a square matrix of order n, then A into Aj is equal to Aj into A is equal to det into I, where I is the identity matrix of order n. A, B. Usually A into B is not equal to B into A. But here the theorem says that A into Aj and Aj into A are both equal, and those values will be equal to determinant A into I, where I is the identity matrix of order n and A will be the square matrix of order n, and this I will also be the same order as that of A. So remember the statement A into Aj is equal to Aj into A is equal to det into I. Now we have a question. Verify that A into Aj is equal to Aj into A is equal to det into I, and the matrix given as 2, 3, minus 4, minus 6. So I gave the name for the matrix as A, 2, 3, minus 4, minus 6. As it is a 2 by 2 matrix, it is very easy to calculate the adjoint. How? Just interchange the main diagonal elements and change the sign of the off diagonal elements. So adjoint A becomes minus 6, 2 in the main diagonal elements and minus 3, 4 in the off diagonal elements. And take the LHS. LHS is A into Aj. So I am multiplying A into Aj. 2, 3, minus 4, minus 6 into minus 6, minus 3. Plus 4, 2. Okay, so 2 into minus 6 gives you minus 12 and 3 into 4 gives you plus 12. The next element is 2 into minus 3 is minus 6. 3 into 2 gives you plus 6. Here, minus 4 into minus 6 is 24. Minus 6 into 4 gives you again minus 24. And the last element is minus 4 into minus 3 is 12. Minus 6 into 2 gives you minus 12. So we are getting the first row as minus 12 plus 12 is 0. Minus 6 plus 6 is again 0. 24 minus 24 0. 12 minus 12 0. So we got A into Aj like this. Again calculate Aj into A. Aj into A is minus 6 minus 3 4 2 into 2 3 minus 4 minus 6. Just calculate the value. Here it is minus 6 into 2 minus 12 and minus 3 into minus 4 is plus 12. Okay, next element minus 6 into 3 is minus 18. Minus 3 into minus 6 is plus 18. Second row 4 into 2 is 8. 2 into minus 4 is minus 8. 4 into 3 is 12. And 2 into minus 6 is minus 12. And you are getting the matrix 0, 0, 0, 0. So we got A into Aj. A into Aj as 0, 0, 0, 0, which is a 0 matrix. And Aj into A also has a 0 matrix of order 2. Again, what all we have to find? Det into I. Calculate determinant A. Do you remember to calculate determinant A? A is the matrix 2, 3, minus 4, minus 6. Okay, so calculating the determinant means product of the main diagonal minus off diagonal. So 2 into minus 6, minus 12, minus 4 into minus 3 is minus 12. So minus 12 plus 12 gives you the value 0. Okay, again det into I. Calculate det into I. That is 0 into unit matrix 1, 0, 0, 1. I took 2 by 2 matrix because the given matrix A was of order 2. 0 into any number or any matrix will give you the value 0. Since it is a matrix, don't write as 0, write as matrix 0, 0, 0, 0. Okay, so we are getting A into Aj equal to Aj into A equal to determinant A into A. Therefore, A into Aj is equal to Aj into A is equal to det into I.